Welcome to Module 3. We're going to start off in Lesson 1. We're going to be looking at graphing quadratic functions. So notice in Module 3 we're dealing with quadratic functions, and I'll explain what those are here in a minute. So first thing that we're going to take a look at is a warm-up, and so this is stuff that we've done before, and that is just looking at if we have a couple of functions or even just one function, and I'm asking to find f of 3. That means that we would look at f of x. We would replace everywhere there's an x with a 3. So we place this with an x. Notice this is g of x, so we would not be working with that one. So we would plug it in here. So if I look at negative 3 there, let's go over here. And notice here are my two functions. And I'm going to plug it in. So I'm going to go ahead and say, okay, we have negative 6 times 3 plus 2. That is negative 18. I should not have another parentheses out here. Hold on, hit the wrong one. Okay, so it's negative 18 plus 2. Oh my goodness. I'm not distributing. I am just multiplying these two together, and then, of course, adding 2, so that would be negative 16. F of n minus 2, I'm still plugging it in there. Everywhere there's an x, I would be plugging in n minus 2, so that would be negative 6 times n minus 2 plus 2. That would be negative 6. Now I'm distributing. Negative 6n plus 12 plus 2 equals negative 6n plus 14. So that would be my final answer there. Okay, g of negative 1 plus 2. Notice the plus 2 is on the outside, so I am just plugging in a negative 1 into that. So I have negative 1 squared. Make sure whenever you have a squared, you put parentheses around it because negative 1 times negative 1 is positive 1. And then minus 2 times negative 1 plus 5. And then right on the outside, I have this plus 2 here, so I add that in there. And so then I go ahead and do the math there. So negative 1 squared is positive 1. Negative 2 times negative 1 is positive 2. Plus 5 plus 2. Add all those up. 3, 4, 5, 10. So my final answer would be 10. So that's how we do the warm-up. You need to do the other ones just to make sure you understand how to do those. I just want to make sure, because especially when we're starting to deal with these types of functions, this is going to be very important. Okay, moving on. A few things that you need to know in terms of the vocabulary. First one is, what is a quadratic function? So if we take a look back at over here, and I did these in front instead of at the end, quadratic function just means that we have an x squared term. Okay, so an x squared term, really we have an x squared term, an x term, and a constant term. And of course, any of those could be missing. A, B, or C could be 0. Those are just values there. But a quadratic function just looks something like that. So it's going to be some type of parabola that either goes up. So this one's going up. This one's going down. And remember here, this is a minimum. And remember, in this case, this is a maximum. Okay, so the axes of symmetry, if we are looking at a quadratic function, right where the vertex is where the axes of symmetry goes through. So this vertical line is considered the axes of symmetry. And the axes of symmetry can be calculated by doing x equals minus b over 2a. Notice we have a, b, and c up here. So if we just plug it into that equation, we can find the x value of the vertex, and then we would just have to calculate the y value. Okay, so going into the vertex is just that particular point there. Remember that a vertex has an x and a y value. The rate of change is just a change in a couple of variables. So as if we look at something specific, and that's what I really wanted to kind of get into. Remember the slope. The slope is y2 minus y1 over x2 minus x1. And that is just the change in y over the change in x. Of course, what does that mean? That means if we start at a certain point, the change in y would be how much we go up or down. The change in x would be how much we go to the right. Remember that we always apply the negative to the change in y, and that way we don't have to worry about the negative part in the change of x. But this little triangle here means change of. Of course, you recognize this as being the slope. And so you've already seen the rate of change being used a lot of times. That's just this particular equation right here. And then the average rate of change, to calculate that, it is f at, f at x2 minus f at x1 all over x2 minus x1. So, whoops. I say it and then I don't write it down. So, minus x1. So in this particular case, we have, notice the average rate of change looks just like the rate of change, you just may not recognize it. F of x2 is really y2. F of x1 is really y1. This is supposed to be a y1, by the way. And here we have x2 minus x1. So this is the average rate of change. Okay, so average rate of change, pretty much meaning the same thing for now. Now, of course, once you move into upper division math classes, this will change. Okay, so those are the definitions that we will be looking at for this lesson. Now, you might remember transforming quadratic functions. Notice here we have ax squared plus bx plus c. That is our function, y equals that, or f of x equals that. And notice if I make, notice in this case, if a is 1, b is 1, c is 1, we just have a normal parabola that's facing up. And if I make a bigger, notice that it goes up faster. If I make a 0, of course, it's a line because a line only has an x value. Notice that this would zero out. And then if it's negative, notice then the parabola goes down. So if a is negative, the parabola goes down. If a is positive, the parabola goes up. And then, of course, if it gets a larger negative number, it goes down faster, and so on. Okay, let's take a look at b. So if b becomes positive, notice what happens with b. So b, the more b gets positive, notice that the function does two things. It moves to the left and it moves down. If b becomes negative, it moves to the right, but it still moves down. Okay? Just to kind of keep in mind, you can at least kind of get a good guess as to what the function is going to do. So c, if the c is positive, notice that the whole function moves up. It doesn't move left or right at all. And if the c is negative, it moves down. And when c is 0, if I can get it to be 0, notice right there, so if c is 0, nothing really happens that's spectacular, but just kind of get an idea of what it's doing as it moves up or it moves down. Okay, so that's kind of important to understand what that is. So you don't have to, put too much weight into that, but that's how that works. Okay, so now graphing quadratic functions. So here we have ax squared plus bx plus c. So a is not equal to 0 because if a was equal to 0, it would be a line. So this is the quadratic term, the linear term, and the constant term. It's linear because x is to the first power, and it's a constant term because we just have a constant there. That's it. Okay, graphing using a table. So graphing using a table isn't exactly the best method to do it, but if we have x squared plus 2x minus 3, and we want to graph it and then state the domain and range, well, we want to graph it first before we state the domain and range. So our first step is to calculate this piece right here, which is the axes of symmetry. Remember at the beginning, I explained what that equation was, minus b over 2a. b is, of course, the value 2. A is the number 1. And c is the number 3. You can see that over here, negative 3. So you can see that over here. So we just plug them in. So we plug in b is 2, a is 1. So we have negative 2 over 2 times 1, which is, of course, negative 1. And that's my x value. So my x value is negative 1. So what's important about that is my axis of symmetry is this value. So x equals -1 is my axis of symmetry. So that's going to be the center of the parabola. Okay? Okay, step number 2, we're going to graph the function. So here we have the x squared plus 2x minus 3, x squared plus 2x minus 3. So if we go over to the graph paper, sorry I set it up for a different one, x squared plus 2x minus 3, and that equals y or f of x, it doesn't matter. We know that x is equal to -1 is my axis of symmetry. Let's just make sure that all those numbers are correct. So x squared plus 2x minus 3 and x equals -1. Okay, so in that case, we've got it. So x equals -1. So right here, I know that my line isn't perfect, but that's where the axis of symmetry is. So I know that much. That means that the parabola is equal on this side and equal distance on this side. So we can figure that out based on what we do there. So that much we know. So we're starting to graph it and figure it out. Now notice at -1, we're going to figure out what the y value is. So what we're going to do is we're going to plug it in. -1 plugs in here, so it's -1 squared plus 2 times -1 minus 3, which comes out to be -4. So -1, -4. So if I come over here, I know that -1, 1, 2, 3, 4. So there is my vertex right down there. Okay, now I know that my a value is positive. Okay, a is equal to 1, positive 1. So that means it's going up. So I'm going to pick points on both sides of this -1. So I'm going to pick 0. So if I plug in 0, it's -3. That's really easy. So 0, -3. Remember that the axis of symmetry acts like a mirror. So I know on the other side it has to look like that. We're then going to pick value of 1. So 1 squared is 1, plus 2 times 1 is 2. 1 plus 2 is 3. 3 minus 3 is 0. So -3 is 0. So, and I'm going to show you a little trick here. So, sorry, I think that is 0, -3. I don't know why I said -3, 0. So it should be 0, -3. So, oh no, wait a second. Never mind. My other point, I don't know why they said -3, 0. That was throwing me off. It should be 1, 0. So they have a mistake here. That should be 1, 0. Okay, so that means we go over 1 and do not go up any. And that means over on the other side, we do that over there. Okay, and there's my parabola. Anytime you're graphing a parabola, you need to use 5 points. You need to have 5 points. Don't make it go straight up. It should still be kind of stretching out, not very far, but it should not be going straight up at all. So that would be this problem here, and that would be example number 1. Okay, so we can graph those. Analyzing the graph is a little bit different. So when we want to analyze the graph, we want to figure out what is our domain and range. So if we take a look at our graph here. So here we have our graph of this one. Notice that my domain, because it's continuing to go this way and it's continuing to go that way, my domain is going to be -infinity is less than x. You need to learn how to write it exactly like this, to positive infinity. And on the y value, notice that my lowest value is -4. So I have -4 and it's equal to it. So -4 is less than or equal to y, which is less than infinity because it goes all the way up to the top forever. And there's my domain. Okay, so that's a good example. We're going to do one on our own, and we're going to see which one actually works out. So we know it's -x squared, which means that the parabola is going down. So it has to be either B or D for sure. We need to figure out the axes of symmetry. So either the axis of symmetry is -2 or the axis of symmetry is +2. So if we look at this value here, we have A is -1, B is 4. So A is -1, b is 4. So let's go back over here. So we know, I'm going to try to keep this all on one page here if I can. So we know that a is -1 and b is 4. So x equals negative b over 2a. And if I plug those in, I get -4 over 2 times -1. The two negatives cancel each other, so we just get 4 over 2, which is positive 2. So of course, if I get positive 2, it has to be d. Okay, and then based on this, what is my domain? It's all real numbers. So all real numbers, all real numbers, all real numbers. So it cannot be d because it runs all the way across here. And then it starts at, it starts at negative infinity down here and goes all the way up to 1, 2, 3, 4, 5. So it goes up to 5. So that means it's going to be all real numbers, and it's going to be y is what, less than or equal to 5, because it has to be less than or equal to, so it's going to be this one. And the reason why I say less than or equal to, because here's 5 and all the y values are below it. Okay, and that's it. You have a check to do. Should be good to go.